Okay, for this one I'm going to do the same problem, but this time I'm going to use r and theta. It's 1 degree of freedom. You're given one dot term, and you're also given a 1 double dot term, because theta dot is constant, so theta double dot is 0. So that means I can find any 1 dot or 2 dot terms that I want. If you're going to use r and theta, you know you need r dot, r double dot for the equations. So what I'm going to do is find an equation for r. Now I'm going to use this triangle right here, and I say r times the cosine of theta is equal to 4. So I'm going to solve for r. r is equal to 4 times the secant of theta. Now let's find r dot, because I know I need it. So use a chain rule. That would be 4. The derivative of the secant is secant tangent times theta dot. Then I go ahead and do the double dot because I know I need it. R double dot is going to be, and this is a product, so that will be 4 times derivative of the first term. The derivative of the secant is secant tangent times the second term, which is tangent theta, times the third term, theta dot, times the chain rule, times the chain rule, times the third term. Okay. Plus first term, secant theta, times the derivative of the second term, which is the derivative of the tangent, that will be another secant squared, times the chain rule, times the third term, plus first term times the second term times the derivative of the third term. Okay, this guy is 0, and the rest of them are not 0, so you're going to plug in and chug it on out. So here's what I know. I know that theta is equal to 30. Okay, is equal to 30. So I can take that and put it into r, cosine of 30, and solve for r right here. Secant is equal to 1 over the cosine. So if you don't have a secant button, you can do 1 over the cosine anyway. Theta is 30. Theta dot is equal to, I think, 3. Yeah. It's constant, so theta double dot is equal to 0. Okay, so solve for r. This equation right here. Plug in 30. I get that r equals 4.62. You take your theta dot, 3, put it in here. You put in 30 degrees here, 30 degrees here, and you calculate the r dot. I get r dot to be 8. Then you take your 30 degrees, your 3 for theta dot, 3 for theta dot, mush it into there, and you get theta double dot, according to my calculator, is 69.28. Now, the acceleration in polar coordinates is r double dot minus r theta dot squared in the radial plus 2r dot theta dot plus r theta double dot in the transverse in the theta direction. That term is 0, thank goodness, right? Okay, A equals, and then you put in 69.28 minus R is 4.62 times theta dot squared is times 9. That's in the NR direction, plus 2R dot is 8 times theta dot is 3 in the n theta. So let's see, I dot This is 27.7 in R and 48. 48 in theta. And then you want magnitude. So that's going to be the square root of 27.7 squared plus 48 squared. According to my calculator, 55.4, which is exactly what I got last time. So you can do it with this, but I think it's much, well, it's not harder. It's the same kind of thing, but it's a lot more algebra. It takes more time.